Okay, so I'm going to go over the practice problem you guys did in class today. That was a practice problem for the AP test, FRQ. And you were given two functions, 3 minus x squared, y equals 2x. Hopefully you didn't need your graphing calculator to determine that this is 3 minus x squared. So that negative, that's a parabola, so you know parabolas are done when we have a quadratic function. And the exponential, okay? But if you did get stumped and weren't able to determine which one was which, you can always graph it. So you were able to use your graphing calculator. And there it is. So for part A, so 2A, you have to find the area. So one thing that I want you guys to have cleared is that area does not require pi. So some of you guys were writing pi in your formula when you were finding area. So here's a quick reminder. Area was back when we did the integral of the upper function minus the lower function. So it's upper minus the lower when we're integrating with respect to x. And the right function minus the left function when we are integrating with respect to y. Pi doesn't come into play until we talk about volume. Okay, so volume was asked in question 2b, not 2a. 2a was area, 2b was volume. Volume is the one with pi, not area. So hopefully I got that cleared. Now with 2a, what we're going to do is we're going to integrate. So I'm going to integrate with respect to x. Okay, so I'm going to integrate this with respect to x. So I'm going to do the upper function minus the lower function. So area is going to be the integral from a to b. The upper function minus the lower function. Dx. The problem here is that notice that your area, so it's asking for the area S, and area, the region S, has an upper function to the left of this intersection. It's one upper function that's different to the upper function of this region here. So this is where we kind of have to maybe split this up to region 1 or S1, S2. Split it up into two parts. So for the first part, we are going to do the integral from 0 up to whatever that intersection is, and it's going to be top function, which is 2 to the x minus 0, so just 2 to the x, 2 to the x minus 0 dx. But no need to put the minus 0 part, just 2 to the x dx, plus the second part of that region. So the upper function happens to be 3 minus x squared. So 3 minus x squared minus 0, because the lower function happens to be y equals 0. So now it's plus the integral from whatever that intersection is all the way to whatever this is. And we'll determine that using our calculator right now. Okay, I'm just trying to help you set up the integral, and that's 3 minus x squared dx. Okay, so the limits, I'm going to use the graphing calculator. So we want to find this intersection here. Go to second, calculate 5 intersect, and my cursor is already close to that intersection that I want. First curve, yes, so I'm going to hit enter. Second curve, yes, hit enter. And then finally, your intersection is at 1, 2. So we've pretty much determined that this intersection is at 1, 2. Now, to find the intercept, you might find it easiest if you graph the line y equals 0. So y3, y equals 0, hit graph. So now you have a line that's running along the x-axis, and you are going to hit intersect again. So you're going to find this intersection now. So go to second, calculate 5, and now you're going to move your cursor. Oh, see, I don't want this one. I want this graph. So I moved down, so it jumps graph when you go up or down. So going up, moving the cursor up or down, it jumps graphs. So make sure you're on the graph that you want. You want that and that line, the black one on my screen. Hit guess. There it is. So we've established that. So now remember, we're focused on the x values because we are integrating with respect to x. So my first region here will have the integral with limits from 0 to 1. I can go ahead and remove that and write my 1. The second region will keep going from 1 all the way to 1.732058. So we got that. The second one has the integral. So this second region has the integral from 1 to 1.732058 of 3 minus x squared dx. Hopefully you guys aren't having trouble punching this into your graphing calculator. So I don't want to waste time with that. But the answer should. Alright, so once you plug it into the calculator, you should get this 2.2401299989 truncate all around 3 places, and that's your answer. So for part B now, what we have to do is we got to focus on the other region. So region R. So we're focusing on this region here. And now we're focusing on rotating around the line y equals -1, and the line y equals -1 is somewhere down here. So what we have is rectangles. Hold on. So we have rectangles that are going to rotate about the line y equals -1. And we are going to have a gap here. Notice that our rectangles do not border the axis of revolution, so we are going to have a washer. Okay, so this is the washer method. And if you were to visualize what the solid would look like, an infinite amount of rectangles in region R that are rotating about the line y equals -1 would create a solid that looks like. So your solid should look something like this. So this is the washer. This is going to be something like that. We take a single rectangle and focus on that single rectangle and rotate about that line y equals -1. That's a washer. So the formula for the washer is, well, actually, we use the same formula. We just have to pay attention to the little r. So if we use that for 2b, volume is pi times the integral of capital R of x squared minus, and it's going to be lowercase r of x squared with respect to x. We got to find functions for capital R. We need to find functions for little r. So your rectangles, to find the functions for a capital R and little r, you're going to create rectangles that will definitely border the axis of revolution, y equals -1 in this case. So capital R goes from the highest function, which happens to be 3 minus x squared, all the way to the axis of revolution, which is y equals -1. So and by the way, that's from a to b. So what we have is the integral of the highest function being 3 minus x squared minus -1 squared minus, and then the lower function, the little r is going to be the lowest function. So it has to be the lowest function from this shaded region R, and that happens to be 2 to the x minus -1. Squared dx. Okay, we can simplify this. Oh, by the way, we need the limits. So the limits will go from, we're going to use I'm going to use the graphing calculator to calculate that. So using the graphing calculator, you get the intersection. So this is the intersection that we're looking for. So we have this setup now, and we can now pretty much make it look a little nicer. 3, 6, 5, 7, 6 to 0. This is going to be 3 minus x squared plus 1 squared minus 2 to the x plus 1 squared dx, and use your graphing calculator to calculate that. So once you plug it into your calculator, you get this. Notice how easy it was to plug in the function 3 minus x squared plus 1 and 2 to the x plus 1, rather than plugging in this entire mess here. Okay, so thanks to your algebra skills, it's not too hard to get from this step to that step, and this last step is a lot easier to plug into your graphing calculator than it would have been to plug in this step here. Okay, so you might have made a mistake plugging in so many parentheses, and it can cause you a point. So I recommend you simplify as much as you can and then plug it into your calculator. And I do realize that I got the wrong answer because I am just noticing that I think the problem intended you to cover all of this, and it just threw me off from the beginning. We'll go over this in class.